Today we are looking at solving systems of equations with substitution. Our learning targets are that we will be able to solve a system of equations using simple substitution and substitution, and that we will be able to state the solution to a system of equations. So simple substitution is when there are two linear equations that are both in slope-intercept form, and both equations are set equal to y. So for example, we have y is equal to 2x plus 2, and y is equal to negative x plus 4. So simple substitution works like this. Since we can see that both of the equations are equal to y, if this is equal to y, and this is equal to y, then these two expressions, 2x plus 2 and negative x plus 4, have to be equal to each other because they are both equivalent to y. And so we can write an equation that is a one-variable equation, so it'll just have the variable x, and when we have a one-variable equation, we are able to solve for that unknown variable. So let's go ahead and do that. Again, since these expressions are both equal to y, 2x plus 2 is equal to y, and negative x plus 4 is also equal to y, and since we know that y is equal to y by identity property, I can set these two expressions equal to each other as well and solve for my unknown variable x. So I can say 2x plus 2 is equal to negative x plus 4. Now I have a one variable equation. I have two x's, okay, but that's the same variable, so it's called a one variable equation, even though I have x's on both sides of the equal sign. So now I want to combine like terms. I want to get all of my x's together. So I will add x to each side. 2x plus x is 3x. Bring down the plus 2 equals. Negative x plus x is 0. And bring down the 4. So then I'll use my order of operations in reverse now that I've combined like terms. I'll subtract 2 from each side. 3x. 2 minus 2 is 0. Bring down the equals, and 4 minus 2 equals 2. So then I divide each side by 3 to isolate the variable x. 3 divided by 3 is 1, so I get x equals 2/3. So I know the x value for my solution is 2/3, and then once I know the x value, I can substitute that into either equation and solve for the y value. So I'll just substitute it into the first equation. Y is equal to 2x plus 2. So instead of saying 2 times x, I'm going to write the 2 as 2 over 1 because I see that x is a fraction. I'm going to multiply it. So times 2/3, because I just substituted in, instead of x, I substituted in 2/3 because I know x equals 2/3 plus 2. 2 times 2/3 is 4/3, so I have y equals 4/3 plus, and then instead of saying plus 2, I'm just going to go ahead, and I see that I am adding a fraction, so I'll just go ahead and write that 2 as 6/3, so that I have a common denominator, because 6 divided by 3 is equal to 2. So then I have 4/3 plus 6/3 is 10/3, so y is equal to 10/3. So the solution for this system is 2/3, 10/3. Okay, and we'll just box that answer. So when we're solving, we substitute the y in equation 2 with the y in equation 1. So we are going to set the expression 2x plus 2 equal to the expression negative x plus 4, and solve for x. And then once we have x, we will substitute x in to solve for y. And then the last thing we're going to do is we're going to check to make sure that the ordered pair is a solution of both equations. Okay, because remember, this is a line, and we want to make sure that we get the point of intersection. So the point has to be a solution for both equations in order to be a solution for the system of equations. So it's not enough for it to just work in one equation. It has to work in both equations, okay? So let's just go ahead and do the check step right over here. Okay, so our first equation, instead of saying y equals, we will say 10/3 equals. Instead of 2 times x, we'll say 2 times 2/3 plus 2. And then I see that I'm going to be working with thirds, so again, I'm going to write that 2 as 6/3. Okay, so 10/3 equals 2 times 2/3 is 4/3. 4/3 plus 6/3 is 10/3. And 10/3 equals 10/3. So that first equation checks out. And then it also has to work in the second equation. So I'll just do that check step right here since I have a little bit of space. Instead of y equals, I will say 10/3 equals, instead of negative x, I'll say negative 2/3 and then plus 4. But I see that I need a common denominator. So 3 times 4 is 12, so instead of saying plus 4, I'll say plus 12/3, because 12 divided by 3 is equivalent to 4. And then bring down the 10/3 equals, and then negative 2/3 plus 12/3 is 10/3. Okay, just adding there. 10/3 does equal 10/3, so it checked out in the first equation, and it checks in the second equation, so we checked our answer. We know that the solution to the system is 2/3, 10/3. Okay, so let's do a couple more examples here. And this says that they have to be in slope-intercept form, and actually it can be an x equals form as well. It does not have to be the y that is isolated. As you know, simple substitution can work this way as well, where the x is the isolated variable. So this will work when it's in slope-intercept form, because we see that the y's are already isolated, so it's just simple substitution. But this is also simple substitution, so it does not have to be in slope-intercept form. But it does work when it is in slope-intercept form. We can use simple substitution. So number 1, we have y equals 5x minus 3 and y equals 2x plus 9. So we see that these are both equal to y. So if this expression is equal to y and this expression is equal to y, then these two expressions are equal to each other. So we can say that 5x minus 3 is equal to 2x plus 9. Okay, so again, we can do that because they're both equal to y. So 5x minus 3 is equal to 2x plus 9. And now we have a one variable equation. Our only variable is x. Okay, so let's go ahead and solve. We'll subtract 2x from each side. This gives us 3x minus 3 equals 9. And then let's add 3 to each side, which gives us 3x equals 12. And then divide each term by 3 to get x equals 4. Okay, and then once we know that x equals 4, we can go ahead and substitute that into either one of the equations and solve for y. So I'll just use the top equation. It was y equals 5x minus 3. I'll substitute in x with 4. So y equals 5 times 4 minus 3. So y equals 17. Okay, and then let's just do a quick check step. Because we just did all this work, we want to make sure we have the correct answer. So instead of y equals, we'll say 17 equals. Instead of 5 times x, we'll say 5 times 4. And then minus 3, so 17 equals 20 minus 3, 17 equals 17. So it checked out in the first equation, and let's check the second equation. Y equals 2x plus 9. I just wrote down the equation. So 17 equals 2 times 4 plus 9. 17 equals 8 plus 9. So yes, 17 equals 17 does check out. And then let's look at number 2. We have x equals negative 2y minus 7 and x equals 3y plus 8. So if these are both equal to y, then they're both equal to each other. So we can say negative 2y minus 7 equals 3y plus 8. And again, we have a one variable equation, except this time the equation is, or excuse me, this time the variable is y instead of x. So we'll get all of our y's together. I will add 2 y to each side to get negative 7 equals 5y plus 8. Subtract 8 from each side to get negative 15 equals 5y. And then divide each side by 5 to get y equals negative 3. Okay, so we have the y value for our solution, so we can substitute that into either equation and solve for x. So I'll just plug it into the second equation. X equals 3 times negative 3 plus 8. So x equals negative 9 plus 8, so x equals negative 1. Okay, and then we'll just do a quick check step. The first equation, instead of x equals, we have negative 1 equals. Instead of negative 2 times y, we'll say negative 2 times negative 3 minus 7. Negative 2 times negative 3 is a positive 6. And 6 minus 7 is negative 1. So that checks out because negative 1 equals negative 1. Then we'll check the second equation. I'll just check that right down here. Instead of x equals, we say negative 1 equals, instead of 3 times y, we will say 3 times negative 3, and then plus 8. So negative 1 equals negative 9, because 3 times negative 3 is negative 9, plus 8. So negative 9 plus 8 is negative 1. So that checks out as well. Okay, so we just take that extra few seconds to do the check step, because then if you have any mistakes anywhere else, that just gives you a chance to find those mistakes and still get that question correct. Okay, page 2. Okay, and so let's look at, these are special cases. And if you just take a look at these, you can kind of see that these are definitely special, because number 3, we have x is equal to 4y plus 12. And then we also have x is equal to 4y plus 13. So when we look at this, this should be somewhat obvious to us that 4y increased by 12 is not going to be equal to 4y increased by 13. Okay, so they're both equal to x, so therefore they're both equal to each other. And when we try to set that up, 4y plus 12 equals 4y plus 13, okay, we see that 4y is being increased by 12 here, and it's being increased by 13 here. So those can't be equivalent because they're not, 12 is not equal to 13. So when we try to simplify this equation, subtract 4y from each side, we end up with 4y minus 4y is 0. 4y minus 4y is 0. So we end up with this statement, 12 is equal to 13. Well, that's never true. Okay, so this is never true. Okay, 12 is not equal to 13, which means that this linear system has no solution. Okay, so when we are graphing these, we know that these are going to be parallel lines, because parallel lines will never intersect. Okay, and if you're ever not sure if it's a no solution or the infinitely many solutions case, it's helpful if you put them in slope-intercept form, because when you have them in slope-intercept form, it becomes obvious if they are the same line or if they're just the same, if they just have the same slope. Okay, so in this application, when you look at the graph, we will have parallel lines, and parallel lines will never intersect. Okay, so no solution there for number 3. And then when we look at this special case, we can see that these are the same line, and the same line will, the same two lines will obviously intersect everywhere. Okay, so if we went ahead and tried to solve this with simple substitution, we would end up with negative 12x minus 9 equals negative 12x minus 9. And then when we added 12 to each side, we would get negative 9 equals negative 9. Okay, well, that's always true. Okay, and if it's always true, it has infinitely many solutions. Okay, and this is the special case where we have the same line. Okay, so these two lines are equivalent to one another. Okay, so our solution, though, is infinitely many solutions. So every single point on these lines will intersect with every single point on this line intersects with every single point on that line, because they are the same line. Solving systems of equations requires finding a point at which the two lines intersect. If you are using a graph to find the intersection point, or if using a graph to find the point of intersection is inefficient, substitution is another option, okay? Because sometimes we just don't want to graph, or the numbers are really difficult to graph, really, really big or really small. And sometimes we just don't have graph paper, or we don't have access to graphing calculator or graphing tool. So sometimes solving it algebraically is preferred, faster, easier, and just more, or maybe just more accessible because you don't have graphing materials. So substitution requires replacement of one of the two variables. Okay, of one of the two variables, which creates an equation with one variable. An equation with one variable is a solvable equation. So first we are going to, so here are the steps. Isolate a variable in one equation. Okay, replace using parentheses into the other equation. So replace into the other equation using parentheses. Okay, so that's going to result in a one variable equation. So I'm just going to put that little note here. This results in a one variable equation. Okay, third, solve the new equation. And then you'll have one of your variables identified. And so solve the new equation for the variable. Okay, that could be your x or it could be your y, whatever your one variable equation had in it. And then substitute that variable into one of the original equations to solve for the other variable. So next, substitute that variable that you just solved for into one equation to solve for the other variable. answer with an ordered pair and check your answer. So list your answer as an ordered pair and check for accuracy. Okay, so when we look at this example at the bottom of the page, we have x equals 9y minus 2 and 3x plus 13y equals 34. So when we look at this one, we see that the x is already isolated for us, which is really helpful. So since the x is already isolated, I'm going to go ahead and substitute this 9y minus 2 into the other equation instead of x. Again, since 9y minus 2 is equal to x, in my second equation, instead of saying negative 3 times x, I can substitute in, and I can say negative 3 times the quantity, 9y minus 2. Okay, so I'm going to take this equation, I'm going to rewrite it, negative 3, but instead of saying times x, I'm going to say times the quantity 9y minus 2. And then I'm going to continue writing this equation. Okay, so that's what I subbed in, 9y minus 2 instead of x. And then I'm just going to finish copying down the rest of my equation. So negative 3 times x plus 13y equals 34. So now I have a multi-step equation, but it's a one variable equation, meaning I only have y's. I don't have x's and y's. And since I only have y variables, I can solve this equation. So now I'm going to remember my order of operations, GEMS. I'm going to cancel out my grouping symbols by distributing this negative 3. Negative 3 times 9y is negative 27y. Negative 3 times negative 2 is plus 6. And then bring down the plus 13y equals 34. Okay, so then I want to combine like terms. I have negative 27y plus 13y. Negative 27 plus 13 is negative 14. So I have a negative 14y, and then I'm just going to bring down my plus 6 equals 34. Then I'm going to subtract 6 from each side to get 28. Bring down the equals, bring down the negative 14y. So now I have negative 14y equals negative 28. I can divide each side by negative 14 to get y equals negative 2. So now I have the y variable of my ordered pair. I can sub that into either equation. I'm going to use the first equation because it's already isolated for x, and then I'll solve for x. So x is equal to 9y minus 2, and then I'm just going to sub in, and you can draw an arrow here. That might help you when you're doing your homework, just so you kind of remember where did it come from. Okay, so you can just draw an arrow. We're subbing it in there. Okay, so x equals 9 times negative 2 minus 2. So x is equal to negative 18 minus 2. Negative 18 minus 2 is negative 20. So x is equal to negative 20. So our solution is negative 20, negative 2. And then you'd want to do the check step to make sure that you have those, to make sure that your ordered pair is accurate. Okay, just for sake of time, because we have a lot of problems that we want to get through, we are going to omit the check step just for this purpose of making the notes a little bit shorter, but I would highly encourage you to check every single equation on your homework as you're learning how to substitute. Okay, next page. Okay, so we have some examples where the x variable is already solved. It's already isolated for us. So let's take a look at number 1. The y is already isolated, so that's the one that I would want to substitute in. So instead of saying y, here I'm going to sub in 5x minus 7. So I'm going to start with that that second equation, negative 3x, but instead of saying minus 2 times y, I'm going to say minus 2 times the quantity 5x minus 7. So I'm substituting the y with 5x minus 7. And then I do need to use parentheses so that I don't forget that the whole thing is getting multiplied by -2. The y is getting multiplied by -2, not just the first part of the y, the entire y value. Then bring down the equals, -12. So now we are going to carefully distribute this -2 over the quantity 5x minus 7. So we will now have 3x. -2 times positive 5x is minus 10x, and then -2 times -7 is plus 14, and then bring down the equals, -12. Okay, so then we will combine like terms. -3x minus 10x is -13x. Bring down the plus 14 equals -12. Okay, then I'll subtract 14 from each side. I'm running out of space here, so I'm just going to go ahead and do that in my head. Subtract 14, I'm going to end up with -26 and 0. Then I'm going to bring down the -13x, divide each side by -13 to get x equals x equals positive, because a negative divided by a negative is a positive 2. Okay, so I know that my x value is 2. I'm going to sub that in right here. So y equals 5 times 2 minus 7. So y is equal to 10 minus 7. Y is equal to 3. So my y value is 3. My solution is 2, 3. Okay, so when we write ordered pairs, remember our x and y values are separated with a comma. And then we always have our parentheses, because that indicates to the reader that this is an ordered pair to be graphed. Okay, so that's the solution of that first system. Then let's take a look at number 2. And again, you would do the check step on your homework to make sure that you have this correct. For sake of time, we're just going to continue on. So number 2, we have y equals x minus 1, and 2x minus 3y equals -1. So in the top equation, the y is already isolated. So that's what we're going to use for the substitution. So 2x minus 3, but instead of saying minus 3 times y, we're going to say minus 3 times, and then where the y was, we're going to substitute x minus 1 instead of the y. X minus 1, and then bring down the equals -1. Okay, so again, we need to distribute, and we do have a negative to distribute, so we're distributing -3 over the quantity x minus 1. So we have 2x, then -3 times x is -3x, and -3 times -1 is plus 3, and then bring down the equals -1. Okay, then we'll combine like terms. 2x minus 3x is -x. Bring down the plus 3, bring down the equals -1. Subtract 3 from each side, and we get -x equals -4. So let's talk about that. If a -x is a -4, I can either multiply or divide each side by -1. I'll divide. And then a negative divided by a negative is a positive. Negative divided by negative is a positive. So it's always going to be true that if a -x is a -4, then a positive x is a positive 4. Okay, because we're just making each of these the opposite sign that it was here just by dividing by -1, or you could also multiply by -1. So number 2, our x value is positive 4. Okay, and then once we have our x value, we can sub that in here and solve for y. So y is equal to 4. Instead of x minus 1, we're going to say 4 minus 1. So y is equal to 3. So our y value is 3. And again, we would do our check step to make sure that that is correct before we move on. Okay, so this is correct. We are going to move on with our notes just so that we can get some more practice with substituting, but checking it, you would just plug in x and y, 4 and 3, into each equation and make sure that it makes it true. If it doesn't make it true, you have a mistake somewhere, so go back and check. Number 3, the y has been isolated. It's by itself, so y is equal to 4 minus 3x. So we'll go ahead and substitute that in right here for this y. So we have 5x. Instead of minus y, we're going to say minus, well, what is y equal to? 4 minus 3x. And we're going to use parentheses so we don't make any mistakes with our signs. Okay, so instead of 5 minus y, we said 5 minus 4 minus 3x, and then bring down the equals 22. Then we're going to distribute that negative over the quantity 4 minus 3x. So now we have 5x minus 4 plus, because a negative times a negative is a positive, 3x, and then bring down the equals 22. 5x plus 3x is 8x, so 8x, bring down the minus 4 equals 22. Add 4 to each side, add 4 to each side. We end up with, I'm just saving space here, so I'm just going to write that very small, plus 4 plus 4. We end up with 8x equals 26. And then divide each side by 8. 8 divided by 8 is 1. So we get x equals 26/8. Well, 26 and 8 are both even. So 26 divided by 2 is 13. And 8 divided by 2 is 4. So we end up with x is equal to 13/4, comma. And then once we know what x is equal to, we can sub that in and solve for y. So when I look at which equation I want to substitute this into, let's see, this is my x value. Here my x is getting tripled. Here it's being multiplied by 5. I'll use this one. The numbers are just slightly smaller, and then the y is already isolated. So I'm going to use the top equation to plug this into, or substitute this into. So y is equal to 4 minus 3, which I'm going to go ahead and write as 3 over 1, times x, which is 13/4. And then I look to see if I can cross cancel 3 and 4. No, they do not. So I end up with y equals 4 minus 13 times 3 is 39. 39/4. Okay, so then I'm going to change my 4 into 16/4. I'm just actually going to erase that just to save a little space on my paper. So the 4, I see I'm working with fourths. I'm just going to rewrite that with a common denominator. So then I have 16/4 minus 39/4, which is going to give me 3 and 2, so negative 23/4. So y is equal to negative 23/4. Okay, so that's our solution, 13/4, negative 23/4. All right, so then let's go ahead and look at number 4. 3x plus y is equal to 9, and y is equal to 9 minus 3x. So this y is already isolated. I'm going to take advantage of that. I'm going to substitute that in to this top equation. So the y is already isolated, which is helpful. Okay, so my equation is 3x plus y. But instead of saying plus y, I'm going to say plus 9 minus 3x. Okay, and then equals 9. And then we're going to go ahead and combine like terms. We have 3x minus 3x, which is 0. 3x minus 3x equals 0. So we end up with this. We end up with this true statement that 9 equals 9. So this is always true, which means this system has infinitely many solutions. So that's a special case. Infinitely many solutions means that these two lines are actually exactly the same. And then if you're ever not sure and you just want to just double check it, one way you can do that is to put them both in slope-intercept form and then compare. So let's take the top equation. It was So here's how we're going to check that. The infinitely many solutions, which would mean they're exactly the same line. So we're just going to put them both in slope-intercept form. So that top equation was 3x plus y equals 9. I'm just going to subtract 3x from each side, and I get y equals negative 3x plus 9. And then when you look at the second equation, it's y equals 9 minus 3x. So if you just rewrote that in slope-intercept form, put the 9 here, it would be y equals negative 3x plus 9. So they are exactly the same line. So when you graph them, they will intersect everywhere. So they will have infinitely many solutions. All right, so now we're going to look at some examples where neither variable is solved for. So these were really great because here the y was isolated, this y was isolated, this y. So actually they didn't isolate any x values for us, but it was really helpful to have one of the variables already isolated. So these next few problems, they do not give us that little head start. So we are going to have to isolate our own variable. So when I look at number 1, I'm going to choose to isolate this top y. And the reason that I'm going to isolate that variable is because it already has a coefficient of 1. So that just makes it one step shorter for me to isolate that variable than any of the other 3 variables, like the top x or the bottom x or the bottom y. So this variable is the one that I'm going to isolate. So here's the equation. Negative 5x plus y equals negative 3. I'm going to add 5x to each side. And then it gives me y equals 5x minus 3. So that's my equation, y equals 5x minus 3. And then once I have that, I'm just going to substitute it into the other equation. And that's really important. So this is the equation that you rewrote. If you just plug it back into itself, you're going to end up with a true statement like negative 3 equals negative 3 or something like that. So if you rewrote the top equation, you need to substitute it into the bottom equation. Okay, so let's look at the bottom equation. 3x minus 8 times y. But instead of saying 8 times y, I'm going to substitute y with 5x minus 3. And then bring down the equals 24. Okay, so now, again, all I did is I took the top equation, I isolated the variable y, and then I took that and I substituted it into the y in the second equation, the other equation. So now I have a one variable equation. The only variable in this equation is the x. I'm going to go ahead and distribute the negative 8. So I end up with 3x minus 40x plus 24 equals 24. And then positive 3x minus 40x is negative 37x. And then I'm going to go ahead and subtract 24 from each side. Well, I'll do it as a separate step. Subtract 24. This gives me negative 3x equals 0. And then divide each side by negative 3 to get x equals 0. So the x value is 0. And then I'll go ahead and substitute that into either one of the other equations and solve for y. So I'll substitute that into the top equation. Okay, so if x is 0, I will have negative 5 times 0, which is 0, plus y equals negative 3, so y equals negative 3. So my solution is 0, negative 3, and then I would check that in the top equation to make sure it's true. Okay, so let's just do so negative 5 times 0 is 0, plus negative 3, so negative 3 on the left equals negative 3, that's correct. And then let's do just a quick audio check. We'll just check it out loud here. If x is 0, 3 times 0 is 0. And then we have negative 8 or minus 8 times negative 3. So negative 8 times negative 3 is positive 24. So 24 equals 24. That checks out. Okay, so let's take a look at number 2. And first we want to decide which variable we are going to isolate. Okay, the top x, the top y, the bottom x, or the bottom y. We probably want to isolate this bottom x. It already has a coefficient of 1. So let's subtract 4y from each side. I'll make that a little neater. So x is equal to negative 4y plus 2. And then once we have isolated that x, we in the second equation, we will plug that in or substitute that into the top equation. Okay, so bring this equation over. Negative 3 times, instead of saying negative 3 times x, we're going to say negative 3 times the quantity, negative 4y plus 2. And then bring over the minus 4y equals 2. Minus 4y equals 2. So we are going to distribute this negative 3. Okay, negative 3 times negative 4y is 12y. Negative 3 times positive 2 is minus 6. Bring down the minus 4y equals 2. Then we have 12y minus 4y, which gives us 8y. Just combining like terms. And then bring down the minus 6 equals 2. Then we'll add 6 to each side to get 8y equals 8. And then divide each side by 8 to get y equals 1. So we have the y variable, and then once we have the y variable, we'll substitute the y variable back into either one of the equations to get x. So this x is already isolated. I'm going to use this equation. I'm not going to use this rewritten equation, although it would be really convenient to plug it in here. I like to use the actual given equation just in case I made a mistake rewriting the equation. Okay, so I'm going to use that original equation, which was x plus 4y equals 2, and then I'm going to sub in 1 for y. So x plus 4 times 1 equals 2. X plus 4 equals 2. Subtract 4 from each side to get x equals negative 2. And again, we would do a check step on this. I'm going to skip the check step just because I want to be able to get through all of the notes during this class period. Okay, so our solution is negative 2, 1. That's the solution to that linear system. Example 3. So this x is probably the easiest variable to solve for. It already has a coefficient of 1, which is helpful. So I will just add 5y to each side to get x equals 5y minus 7. So then once I have that, I can plug it into this first equation for the x. Okay, so I'm just going to substitute this in here. So here's the original equation, negative 2, but instead of times x, we'll say times the quantity, 5y minus 7. And then bring down the plus 6y equals 6. And then we are distributing not a 2, we're distributing a negative 2. So remember, each term has to be multiplied by negative 2. So negative 2 times positive 5y is negative 10y. Negative 2 times negative 7 is plus 14. Bring down the plus 6y equals 6. Okay, then we're going to combine like terms. We have negative 10y plus 6y, that's negative 4y. Bring down the plus 14 equals 6. Subtract 14 from each side. This gives us negative 4y equals negative 8. And then divide each term by negative 4 to get y equals positive 2. Because a negative divided by negative is a positive. And so then once I know y is negative 2, I can plug that into either equation to solve for x. So I'll use that second equation, x minus 5, but instead of 5 times y, I'm going to say 5 times 2 equals negative 7. So x minus 10 equals negative 7. Add 10 to each side, which gives us x equals 3. So our solution is 3, 2. And then you can substitute that back into both equations, x, y, that ordered pair, into both equations to make sure that that checks out. Okay, example 4. So which variable do you think will be easiest to isolate? Probably this y. So I will add 5x to each side. That will give us y equals 5x plus 19. Okay, so then once I have that, I'm just going to substitute that y variable, the 5x plus 19 here, into that first equation. So negative 3x, so this is coming from here, I'm just bringing this down, minus 8, but instead of times y, I'm going to say times the quantity 5x plus 19, and then equals 20. Okay, so negative 3x. Then negative 8 times negative 5 is negative 40. Don't forget the x. So 20 times 8 would be 160. So 19 times 8 would be 8 less than that, so 152. And then bring down the equals 20. And then combine like terms. Negative 3x minus 40x is negative 43x. Minus 152 equals 20, and then add 152 to each side. This gives us negative 43x equals 172, and then divide by negative 43, and that's going to be times 4, right? Yeah, 4 times 3 would be 12, carry the 1 would give us 17. So x is equal to negative 4, okay? And then once we have the x value, we can plug that into either equation to solve for y, probably this one, negative 5x, it doesn't matter which one you plug it into, plus y equals 19, but instead of x, we're plugging in negative 4. So negative 5 times negative 4 is positive 20. And then bring down the plus y equals 19. Subtract 20 from each side to get y equals negative 1. Okay, so our solution is negative 4, negative 1. Okay, so then number 5, negative 2x minus y equals negative 9, and 5x minus 2y equals 18. I'm probably going to solve for this y because it's already has a coefficient of 1. So I'm just going to rewrite that here. Negative 2x minus y equals negative 9. Add 2x to each side. This gives me negative y equals 2x minus 9. Divide each term by negative 1 to get a positive y equals a negative 2x plus 9. And so since I rewrote the top equation and it's now expressed in terms of expressed as a y equals, I'll substitute that into the second equation. So now this was going to be 5x minus 2 times y, but instead of y, we're substituting in negative 2x plus 9, and then equals 18. Okay, so 5x, and remember you are distributing that negative with the 2. So 5x plus 4x, because 2 times negative 2x is positive 4x, minus 18 equals 18. 5x plus 4x is 9x. Then add 18 to each side. 9x. Negative 18 plus 18 is 0. Bring down the equals. 18 plus 18 is 36. Divide each side by 9 to get x equals 4. So we know the x coordinate of our solution is 4. And then once we know that, we can substitute that into either equation to solve for y. You could plug it in here if you're really confident with your math, but I always like to go back to that, one of the original equations, so I know that I'm checking it here. So let's do the top equation. So negative 2 times 4 minus y equals negative 9. Negative 2 times positive 4 is negative 8. Minus y equals negative 9. Add 8 to each side, and we get negative y equals negative 1. If a negative y is a negative 1, then a positive y is a positive 1. So y equals 1. And again, you would do a check step to make sure that this ordered pair satisfies not just one of the equations, but both of the equations. You would do a check step. Number 6. I would isolate this bottom y because it already has a coefficient of 1. So we'll add 5x to each side. This will give us y equals 5x plus 13. And so then, since I rewrote the bottom equation, I'm going to substitute it into the top equation. So negative 3x plus 3 times the quantity 5x plus 13 equals 3. Okay, so then we're going to go ahead and distribute this 3 over the quantity 5x plus 13. So we get negative 3x plus 15x plus 39 equals 3. Negative 3x plus 15x is 12x. Bring down the plus 39 equals 3. Subtract 39 from each side to get 12x equals negative 36. Divide each side by 12 to get x equals negative 3. Okay, and then once we have x equals negative 3, you can plug that into either one of these equations to solve for y. So I'll use the top equation, negative 3, but instead of x, we're plugging in negative 3. So negative 3 times negative 3 plus 3y equals 3. So again, I just took this equation, I rewrote it here, but I put this in for x. So now I'm solving for y. Negative 3 times negative 3 is positive 9. Bring down the plus 3y equals 3. Subtract 9 from each side. This gives you 3y equals negative 6. Then divide each side by 3 to get y equals negative 2. So our solution is negative 3, negative 2. Okay, so really nice job with substituting with 2 variables. So let's go ahead and do a couple problems where we have 3 variables. Okay, so in number 1 down here, we have x, y, and z. And we will notice that that last equation has just x equals 6. So this is already solved for us. So then we're not going to go into the equation that has x and y and z and try to solve. Since we know that x is equal to 6, that's given, we'll sub that in here for x so we can solve for y. So again, we're just subbing this 6 in for x here, which is going to give us a 1 variable equation, and we can solve for y. So instead of 4 times x plus y equals 25, we'll say 4 times 6. So I'm just rewriting this equation right here. Okay, but I'm plugging in 6 for x. So 4 times 6 plus y equals 25. 4 times 6 is 24. Bring down the plus y equals 25. Subtract 24 from each side to isolate the variable y. This gives us y equals 1. Okay, so we know y equals 1. We know x equals 6. That's enough information for us to solve for z. Okay, so instead I'm going to take this equation and write it here for x. I'll write the original equation, plus y plus 3z equals 31. And we don't write the slash through our z because we think it's fancy. We write the slash through our z just to prevent it from looking like 32. Okay, so it's obvious that it's a 3z and not a 32. Okay, so then we have 4 times 6 plus, we subbed in the 6 for x. Now we will sub in the 1 for y. Bring down the plus 3z equals 31. Okay, so 6 times 4 is 24. Bring down the plus 1 plus 3z equals 31. 24 plus 1 is 25. Bring everything else down. Subtract 25 from each side. This gives us 3z equals 6. Divide each side by 3 to get z equals 2. So now when we write an ordered triple, that's an x, y, z. Oops, there's my rest of my equation there. So we'll write them in, it's always alphabetical order. So it's going to be x is 6, so 6 comma, y is next alphabetically, so y is 1, and z is last alphabetically, and that's 2. And remember, so this is x comma, y comma, z. It's an ordered triple. Okay, so if you were graphing in a three-dimensional space, you would have your length, width, or how far left, how far right, but then that's on a flat plane, but then you would also be working in three-dimensional space. So x, y, z. Then let's take a look at number 2. Okay, again, we have 3 variables. We have x, y, and z. Z is already solved for us as 3. So then I look and I see that the equation just above it only has 2 variables, z and y. So I'm going to sub the 3 in for the z here. Okay, so instead of 3 times z, I'll say 3 times 3. This is the equation that I'm rewriting. Okay, and I'm subbing in the z with a 3. So 3 times 3 plus 4y equals 33. So this gives me 9 plus 4y equals 33. Subtract 9 from each side. So this gives me 4y equals 24. And then divide each side by 4 to get y equals 6. Okay, so my ordered pair, I don't know x yet. I know that y is 6, and I know that z is 3. Okay, so now I need to solve for x. This is my only equation that has the x variable, so I'm going to go ahead and write that here. 4x plus 5 times y, I know y is 6, so plus 5 times 6, plus 2 times z, so plus 2 times 3, equals 44. Okay, bring down the 4x. 5 times 6 is 30. 2 times 3 is 6. Okay, so now I have 4x. 30 plus 6 is 36. Okay, 4x plus 36 equals 44. Subtract 36 from each side. Then 36 minus 36 is 0, so bring down the 4x. Divide each side by 4 to get x equals 2. So we get 2, 6, 3 for our ordered triple. So what patterns do you see throughout these problems that make substitution a viable option for solving these systems? So it's helpful. So we can substitute. We can isolate a variable to substitute into one of the other equations to make a one variable equation. So we can isolate one of the variables and it doesn't matter which one, in order to sub it into the other equation, to create a solvable one variable equation. Okay, so that basically you're just taking one variable, you're isolating it, you substitute that into your other equation, simplify and solve for that second variable. And then if you have a 3-variable equation, you're doing that one additional time to solve, so that you have solved for all 3 equations. So that is solving systems of equations with substitution.